Hello, explorer. Welcome along. It's time to quickly leave planet Earth. We'll be back in about half an hour. In that time, let's search out some of the universe's secrets. It's a brand new Fun Kids Science Weekly. My name is Dan, and this week on the podcast, we're finding out why our Earth might have once looked like a gigantic snowball. We're heading back 720 million years to find out why.
This ice age in Scotland would have lasted around 60 million years. It's between the ages of around 720 million years ago to around 660 million years ago. That's about the same length of time as between us and the dinosaurs.
Also, in our quest to find the greatest science ever, we're hearing about something quite unique and unusual. It's not a hands-on science, it's more of a thoughtful one. We'll look at the philosophy of science.
So I think the mind is a product of the brain. And I think the more we understand the brain, the more we're going to understand the mind. So if we study the brain using psychology and brain science, then we'll understand our emotions, our thoughts, our consciousness.
And we're heading down to the deepest parts of the ocean for today's Dangerous Dan. Things get quite strange down there, don't they? Let's get to it. It's a brand new Fun Kids Science Weekly. And let's kick things off with your science in the news. A rocket engine has exploded during a launch test at the UK's new spaceport in Shetland, which is an island off the very north coast of Scotland. The test was being carried out by a German company called RFA, who hope to eventually launch the UK's first vertical rocket into orbit. They've never been done before, so they're testing to make sure how it can happen. Now, RFA said no one was injured in the explosion, and the launch pad had been saved and is secured. A spokesman from Saxavord Spaceport up in Shetland says this was a test, and test campaigns are designed to identify issues. So, while it's never good to hear loads of money, loads of work has been exploded, but that's what tests are for. So it's brilliant news that they can find out what's making this issue so it can keep everyone and keep astronauts safe in the future. And speaking of astronauts, 2 American astronauts who blasted off on a test mission to the International Space Station in June thought they'd be home just a few days later. Things didn't go to plan though. Barry Wilmore and Sunita Williams are still there, floating above Earth nearly 2 months later. The spacecraft they used to fly there had its problems as it landed at the ISS. So whilst the humans arrived safely, they might need a different mode of transport to get home. NASA has said no firm decisions have been made about next steps, but they want to use the first spacecraft that they went up there with to try and get back home, but they think they might need other options. It turns out Barry and Sunita might be up there for 5 months until 2025. How mind-blowing would that be? You go up into space, which is pretty awesome. You think you'll be there for a few days, then you'll be back home to see their family. Turns out you might be there for almost half a year. I hope Barry and Sunita do really, really well and they keep everything together, and we're excited to get them back on planet Earth. And our last story this week, a cluster of Scottish islands could help solve one of our planet's greatest mysteries. That's what scientists say. The Garvalach Islands off the coast of Scotland are the best record of Earth entering its biggest ever ice age. They call it the Snowball Earth. It was around 720 million years ago. Let's find out more with a researcher who helped discover it. From University College London, Elias Rugen joins us. Elias, thank you for being there. What do we mean by a snowball Earth?
A snowball Earth glaciation is in effect when ice covers nearly the entire planet. So that would be all the way from the poles of our planet down to the equator. So, if you're looking at it from outer space, the Earth would look a little bit like a snowball, hence the name Snowball Earth, which makes it different to other glaciations that we've had, which, as soon as they get to the equator, it gets a little bit hot for ice to form, and subsequently we don't enter what's known as a Snowball Earth glaciation.
Now, we've heard about ice ages before, and they always seem so mythical, don't they? It's really hard for us to focus on the fact that This would have been Earth at one point. How long does this ice age, 720 million years ago, how long do we know it lasted for?
Yeah, this is one thing that the team of scientists that I've been working with, and including myself, have found out that this ice age in Scotland would have lasted around 60 million years. It's between the ages of around 720 million years ago to around 660 million years ago. Now, to put that length of time into perspective, that's about the same length of time as between us and the dinosaurs. So it's an incredible amount of time for Earth to have been encased nearly entirely with ice.
And what do we know about what causes an ice age generally?
Yeah, well, Earth seems to go through regular cycles in its climate. We fluctuate between times when Earth is warmer and times when Earth tends to be colder and ice forms. You know, we're technically in an ice house climate now because we have ice at our poles and we have ice on land in large amounts in places like Greenland. However, Earth is a very intricate system, and if you see it as a system as a whole, Earth has mechanisms which basically stop it getting too hot or too cold for too long. So normal glaciations usually last on the order of thousands of years. Now that sounds a lot to you or I, but in geological terms, that's, the blink of an eye. Whereas this Snowball Earth glaciation that happened 720 million years ago, we don't fully understand why Earth was, let's say, pushed into a Snowball Earth glaciation and why it lasted for so long. But we see that CO2 is warming the planet today. And Earth also has mechanisms to capture CO2 and to draw down carbon dioxide to cool the planet. So geologists think that the Snowball Earth, there must have been some sort of perfect storm, a number of different things that actually drew down lots and lots of CO2 from the atmosphere, cooling it significantly, and which led into this Snowball Earth phase. Probably the most interesting point of Snowball Earth glaciation is that it reached equatorial latitudes. It reached places like modern-day Bahamas, which if you think of that, it's like having Antarctic ice sheets over modern-day Bahamas, which is quite a difficult image to conjure in your head. But basically, if ice passes 30 degrees latitude, which is when you get to that equatorial region on Earth, ice is very reflective and it reflects a lot of heat. And that's a process called albedo. Now, when it gets to that 30-degree latitude, albedo, there's so much reflection going on because there's so much ice that the heat is being lost so rapidly at Earth, you have what's called a runaway albedo effect, which is basically a really rapid descent into a Snowball Earth glaciation. So we kind of have some sort of idea that this might have been the cause of Snowball Earth.
So let's head up to the Garvalak Islands then, off the west coast of Scotland. I know that you were pretty important in this discovery. So what have you found up there?
Yeah, so these rocks just off the coast of West Scotland, this chain of islands called the Garvalaks, they preserve one of these Snowball Earth glaciations. Now, for those that don't know, the geological record can be read like pages of a book, or every different layer preserves a different interval of time in Earth's history. And what we have on the Garvalak Islands is this particular event in Earth history, this Snowball Earth glaciation. So we hop off the boat, because we have to get a boat to these islands. They're uninhabited, so we have to kind of jump off the side of the boat, if you like, onto the island. And we're looking primarily for observations. But what we also do is we take samples of this glacial rock and we use different minerals from that rock, which we can date to provide age constraints. And it's these ages that we have just published in the scientific article. And it's these ages which tell us how old the glaciation is and how long it lasted.
So how might this change the future of what we think about this ice age that happened 720 million years ago?
Well, that's a good question. As geologists, we're constantly developing this picture, which is Snowball Earth. This is a theory that's been around for, let's say, some 30, 40 years. However, the more and more evidence we get, such as these evidence we've got now in Scotland, the broader picture we can build up that we did truly have this ice-covered planet for such a long, long time. So that's in effect what this new data can tell us. It kind of really solidifies that Snowball Earth story.
Well, it's been delightful to hear all about it. Snowball Earth. Elias Rugen, thank you so much for joining us.
Thanks for having me.
Thank you so much to Elias Rugen for coming on the show. Can you just picture that? Our planet covered in ice. Looks like a massive snowball spinning around the sun. Isn't it mind-blowing as well, time frames, that this happened so long ago when the Earth was still around? It's really hard to get your brain around the years and the distances and the times involved in something like that, I think. Let's get to your questions then. If you ever have anything sciencey that you want answered on this show, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. I will do the digging. We will sort it out for you. This has been dropped as a message to me by Eden, who wants to know, why do we sweat? Well, the main reason is to cool us down. At school, you might have learned about evaporation. That's when liquids are heated up, they become a gas. And because the liquid is being heated up, it's drawing away a lot of temperature. Well, it's a very similar thing. When your body temperature rises to a certain level, you make sweat because it's not good for you to be too hot internally. Now, sweat is mostly water with a little bit of salt in there. And that sweat then evaporates because that's what happens when water and heat mix together. That sweat becomes a gas. And in doing so, it sucks the heat out from your body, which cools you down. It's a very smart way of keeping your temperature in a safe range. And you might notice that some animals around the world can't sweat properly, so they have to keep dousing themselves in water. That's why your dog, if you have one, when it's out on a walk, they don't properly sweat, so they have to run into rivers and lakes and streams to cool down. It's why hippos and elephants in Africa are always in swamps and in massive pools of water, because they need to get it over themselves, so it evaporates off and it sucks that heat from out of them. Thank you so much for the question, Eden. Let's get on a voice note then. This is from Alara.
My question is, why does February get affected by the leap year rather than any other month?
Hey, Alara, thank you so much for sending that over to the free Fun Kids app. Why does February have a leap year day as opposed to any other month? Now, I'm going to sort this for you, Alara. I will say there's a lot of history, there's a lot of dates, and there's a lot of random decisions that have been made that have led to the point. Let's try and figure it out. So our modern calendar is based on the original Roman calendar, which only had 10 months. Winter was still around. Winter was in January and February, but they weren't official months. The calendar had 304 days. It went from March to December. We have over 365 days. The over bit is very important. I'll tell you more in a sec. Then, around 713 BCE, the Roman king Numa Pompilius officially added January and February as proper months. So the calendar had 12 months then. The problem was the total days didn't accurately match the solar year, which is 365 and a quarter days. That's how long it takes our Earth to complete one full orbit of the sun. And February, one of the new added months, was given 28 days. It was put right at the end of the year because even numbers were thought to be unlucky by the Romans. Hard to get your head around. They thought, it's an unlucky amount of days, it has to have 28 days, so let's shove it at the end of the month. Anyway. Then, Julius Caesar, famous Roman emperor, came along with another calendar because all the dates, all the timings, it had gone wrong over the years because of the strange amount of days and months and everything. So, Julius Caesar's new calendar added the leap year because the official year is 365 and a quarter days long. So you've got the quarter. Every 4 years, those quarters add up to make one extra day. That's why we have a leap year to even things out. They gave that day to February because it was the shortest month anyway. So it was natural to bring it a bit closer to the rest. And that's why February has the leap year day. As I say, a lot of dates and a lot of strange decisions in there. Thank you very much for the question, Alara. If you have anything you want answered on the show next week, anything sciencey at all, make sure you leave it as a voice note for me on the free Fun Kids app. And you can do it at funkidslive.com too. Now, for this week's Dangerous Dan, we are headed down, way down to the deepest parts of the ocean to meet a very strange beast that we know very little about. Around 1,000 metres below sea level, swimming about the ocean, you might find the frilled shark. It's a deep-sea predator. It looks very snake-like. It's rarely seen by us humans because it lives so far down, but when we have seen it, we call it a living fossil. It looks ancient, like something from another time, another world. It's got a long body. It can grow to about 2 metres, which is long. It's slim, it's sleek. Picture it more like an eel than a traditional shark. It's got over 300 teeth, shaped like a forked trident they are. Perfect for snagging slippery prey. They also curve inwards, which means the prey they snag can't really escape. They've got a huge mouth, which opens, it billows outwards. Now, its name comes from 6 pairs of frilly gill slits on its throat. That's how it breathes, and it helps it look so old. Their hunting method seems amazing. It doesn't really chase like other fast predators. Instead, it bides its time, it waits, and then it lunges with an incredible burst of devastating speed and swallows its prey whole. That big jaw expands extremely wide, which means it can take down much bigger creatures. It's rare, it's mysterious. We don't know much about it, but what we do know about the frilled shark definitely puts it straight on our Dangerous Dan list. It's time for Battle of the Sciences, where every week we try to uncover for once and for all, finally, what is the greatest science in the universe. This week, something a little bit unusual. Something a bit more ideasy, I think. Maybe not as hands-on as you might normally expect. We are talking about the philosophy of science. Dr. Henry Taylor joins us from the University of Birmingham. Henry, thank you for being there. You have 1 minute to tell us why philosophy of science is the greatest. That minute starts in 3, 2, 1, go!
So philosophy of science, basically what I do is I look at loads and loads of different scientists' work, and I try and use logic to draw together all those results and come up with much more big picture theories about how the world works. So for me personally, I'm really interested in the mind. So I'm interested in thoughts and emotions and things like consciousness and how our brains produce them. The reason I think it's the best kind of science, or the best area of science, is because you get to look at all different things day by day. So because I draw together lots of different kinds of scientists' work, one day I'll be reading about how vision works and how we're able to see things. The next day I'll be reading about how you remember things and why you forget stuff. Then I'll be reading about what's going on in your brain when you're angry or happy or sad. And then the day after that, I might be reading about robots. This morning I was reading about how bees reproduce. So basically you get to take all the best, coolest, most interesting bits of all the different sciences and draw them together.
And there's your minute, Henry. Thank you so much. Wow. I've spoken to a lot of scientists, and as I said at the start, they're hands-on on their own research quite a lot of the time. Whereas you are, you're finding what interests you, and weave almost a story, a big picture out of it, which is fascinating. What is the big picture? What is the grand question that you are interested in with the philosophy of science? If you're looking at how the mind works, about consciousness, so how much we are aware of things, what's the big thing that you want to uncover with everything?
Well, so my opinion, I think the mind is a biological thing. So I think the mind is a product of the brain. And I think the more we understand the brain, the more we're going to understand the mind. So if we study the brain using psychology and brain science, then we'll understand our emotions, our thoughts, our consciousness. That's my general sort of picture. But once you believe that, then all sorts of other questions start to arise. So you might think, well, if we're conscious, then how far does consciousness go? So most people think dogs and cats are conscious. It's really hard to own a dog and not think that it's conscious. But it's not quite so clear when you start thinking about things like ants and fish and octopuses, things like that. We're not really sure when infants become conscious. Like, are you born conscious? Or do you have to grow into consciousness? And also things like robots as well and computer systems. So could a robot ever be conscious? Could it ever have thoughts? Could it ever participate in culture? Those are the kinds of questions I'm interested in. So I'm interested in how far the mind goes throughout nature, basically.
When you say consciousness, are you meaning we are aware of us being humans and the fact we can think?
Yeah, sort of. So basically, the easiest way to get it is like, imagine the difference between what it's like to be you and what it's like to be a rock. So when you look out at the world, you see greens, you see colors, you see shapes, you see objects, and you see them, you have them there in your. It's kind of, there's something it's like to be you. There's something it's like to see a tree, or to smell your favorite food, or to taste your favorite food, or to hear a drum, or something like that. What's it like to be a rock? It's not like anything. It's lights off. There's nothing there at all. It's not like the rock sits there looking at stuff. There is nothing in the rock. And that's the difference. Consciousness is what it's like to have a perspective on the world, is to look out and experience that, what a tree looks like, what a cake tastes like. That's what consciousness is. It's the difference between you and a rock, basically.
It's a really interesting balance of old and new, I would imagine, too, because philosophy is, well, way old. Like, people since humans have been around have been wondering why we're here, how we think, how do I think differently from you? Whereas, well, science and what we can do with science now is pretty recent in the grand scheme of things. For how long do you know have people been using science to try and explain the big questions of the world with philosophy?
Oh, well, what's interesting is these days we tend to see science and philosophy as different, but of course that's actually quite recent. So back in the day, people like Isaac Newton, for example, would have called themselves natural philosophers. So there used to not really be as much of a split between philosophy and science. So, for example, people like Newton, they're remembered as being physicists, but really his work was just as much philosophy as it was science. So if you look back at the really old folks like Aristotle, they do just as much philosophy as science, and they wouldn't have seen a distinction between them. So actually, the idea that science and philosophy is separate is actually quite a recent one. So I'd say that science and philosophy are as old as each other, and they go back thousands of years, because it's only very recently that we've seen them as different things.
Now, I always finish these chats with experts like yourself in exactly the same way. I'd like to throw you forward, but 20, 30 years, whenever it is, you stop. You take off your lab coat if you wear one. You got to start stroking your beard and asking big questions. What's the one thing that you really want to know? What's the one question that you're just so eager to answer in your field?
Oh, that's really, really easy. How do our brains produce the mind? What is it about the brain that does all its different complicated bits and pieces? How does it manage to put itself together in such a way as to produce vision, hearing, emotions, thoughts? How does the mind come out of the brain? If indeed my hunch is right, and that it does. I could always be wrong, obviously.
Wow, it's been amazing to hear. Such a unique expertise for the podcast, so I'm really, really thankful. Dr. Henry Taylor, thank you for joining us.
Thank you very much for having me.
Thank you so much to Henry Taylor for coming on, Dr. Henry Taylor. It's one of my favourite parts of the show that we're doing at the moment. We get to learn about so many different sciences, stuff that you know about, and things that are unusual and unique, like the philosophy of science. Brilliant to hear about that. Also, earlier on in the show, we caught up with Elias Rugen, didn't we? Who was telling us all about rocks up in Scotland and glaciers and how they help us track how old the Earth is. Well, let's find out more with an episode from our Geology Rocks series. In this, we join Finley as he travels around the world and heads back in time to explore everything from fossils to volcanoes and learns how rock formed our planet. And this week, we're taking a look at how climate change is caused, how it's affecting all of us, and we're heading back 55 million years ago to learn more. Let's get to it.
Geology Rocks! The Geological Society!
It's thirsty work looking for fossils, but it's so hot today. The ice cubes in my squash are melting faster than I can drink it. I think I need a few more cubes. Much better. My melting ice has got something in common with our planet. Ice is melting into the sea at the North and South Poles, and the scary thing is, it's melting faster than it has for thousands of years. You might know from school that when fuels like coal and oil are burned, they fill the atmosphere with carbon dioxide, which traps heat around the Earth. This makes our climate change and get hotter, and that's what melts the ice. You might not know that this has happened before on Earth. Do you want to take a look? Let's travel back 55 million years ago to the end of the Paleocene epoch. It's pretty nice here. Dinosaurs died out 10 million years ago, and so there were lots of very happy mammals who were enjoying minding their own business and being in charge. But at the end of this period, things got much worse. Let's get out the rain. No one really knows why, but lots of carbon dioxide began to be released just like today. Now, we're releasing lots of carbon dioxide when we burn fuels like coal and oil. But there wasn't any people driving cars back then, so where did it all come from? It's a real puzzle, but we do know what happened next. The Earth got a lot hotter. Oceans became more acidic and lots of deep ocean creatures died out. It didn't take long, just 20,000 years. Nothing to a planet as old as our Earth. Just imagine all the life on the deep sea floor wiped out in such a short space of time. It wasn't a very nice place to be on land either. Far too hot. Let's go home. Phew, that's better. So anyway, after the hot event at the end of the Paleocene, a new epoch started, the Eocene. Temperatures were still pretty hot, and there were some different plants and animals. And here's the really scary bit. Because geologists can tell all of this from evidence left in rocks, they can tell that a similar hot event might happen again. And just like then, we have increasing levels of carbon dioxide and the climate is warming. So what might come next? Maybe a new epoch will start, and maybe it won't be such a nice place to live. It will be hotter than now, and the melting ice will make the sea level rise. The sooner we can find other ways to get our energy and stop burning carbon-based fuels like coal and oil, the more likely it is we won't have to find out.
Geology Picks.
Did you know that all the coal and oil we burn comes from the remains of living things? The coal comes from dead trees, and a lot of the oil comes from plankton that lived in the sea. Over millions of years, their remains decomposed and became trapped inside rocks until nothing was left except sticky, oozy oil or lumps of coal. Time to go! See you again soon. In the meantime, find out more on the Fun Kids website.
Geology rocks! The Geological Society!
And that is it for this week's episode of the podcast. Thank you so much for listening. Thank you to all our guests. We had Dr. Henry Taylor on. We had Elias Rugen with us too. We'll be back with more adventures exploring the universe, same time, same place next week. You've heard Geology Rocks today. We've got loads more brilliant podcast series like that on Google, Apple, Spotify, wherever you get your shows. You can send a voice note to me on the free Fun Kids app and at funkidslive.com too. And Fun Kids, we are a children's radio station. You can listen to us all over the country, on the app, on the website, and if you've got a smart speaker, wake it up and ask it to play Fun Kids.